Hi all, this is our third lab on road to CCNA, and today we are going to learn about OSPF or Open Shortest Path First. Yesterday we have seen static routing. In static routing, what we have done is specifying routes manually by ourselves, like using a command IP route and defining the routing paths between the different networks to other networks. It is really time taking, and the process might take really longer time if we have a bigger network or medium sized enterprise. But we have a small office, small networks, one or two or three. We can define static routing, but we have more networks like 10, 20, 30. We have to use open shortest path first or RIP or BGP protocols, making it convenient and making the routers to learn the networks dynamically. And let's see some explanation that we have done here. And OSPF on single area, there are two modes. One is OSPF single area and another one is OSPF multi-area. For today we see OSPF single area, and the next video we will continue with the OSPF multi-area. Let's see open what is the OSPF and its a little of explanation about OSPF. OSPF stands for Open Shortest Path First, and protocol number is 89, and the administrative distance value is 110. And the OSPF maintains three tables: neighbor table, database table, and routing table. And also we have a few more about OSPF. If you want to know, I will tell you right now. It will be the OSPF also maintains of 5 packets. One is a hello, DVD or database description, request, update, acknowledgement. These packets sent to initiate a communication between the two routers. If we have R1 and R2, if we want to initiate the network, and if you want to share the data, and first of all the OSPF configures, and then the communication done by the packets first sending the hello packet, and then sending the database description after initiating the connection. And the third one is requesting the services, and the updating if there is any changes in the network, and acknowledgement given to what is the when you uh, done any updates, and it will give you a compliment like reply. We can say reply for the acknowledgement. And if it goes for the few more away, we will say the OSPF maintains three types of network: P2P, broadcast, and other one is multicast. And this all will be longer, lengthy, and this is not really included in a single area. We will discuss it in a multi-area. And what we been doing the OSPF to use it for, there we see here I have mentioned, if there is a medium sized enterprise with many routers, it will be very hard to manage with a static routing. As I told you, you have to take each of the adjacent and non-adjacent networks, and you have to configure the routing paths, and it will be very messy and really longer, and it's impossible even you have more than 10, 20, 30 networks or routers. But if you use the OSPF, it will be very easy and stable. It the networks learn dynamically what routings are configured and what routing paths are there, so you don't need to be having much of the time to configure in the routing paths. So the next one, what the OSPF do is, it is used to finding the best routing path that can be used to route the traffic from one network to other network. It will find the best routing path. If you have three routing paths from R1 to R2, and middle you have connected with R3, R4, R5, and you want to know which one is the best path to reach the data from R1 to R2, it will be R3, or you consider you have a R7 and R1 and R7, maybe you have five routers or five networks, and if you want to know which one is the best router 2 or best routing path to know the data will be transferred to router 7, we have to configure the OSPF into the router 1 to router 7, and it will automatically learn which would be the better path to route the traffic from R1 to R2. This is a small description about the OSPF on single area. Let's see the configuration right now. I already created a topology for the OSPF single area, and I forgot to maintain. What is single area? A single area is nothing but a grouping uh, different multiple routers in a single block or single area. Let me create one area here. Let's say I forgot to mention the area before, but right now I'm giving what is area. And here we see, let's let's say this Eclipse is a single area or single city, and in this single city you have three routers and two PCs. Let's consider this area 0. This is also called backbone area, and let's pull it to the down. Sorry, and here we have area 0, and in this, sorry for this inconvenience, and here you have router 1, router 2, and router 3, and this router 1 connected with the LAN network with the PC1, and R3 connected with a one LAN network that has a IP of 20.2 and R1 with a 10.1, and R2 is in a middle between R3 and R1, and right now we have to configure these three routers with the OSPF to learn the networks automatically by itself. And let's see if by pinging from PC1 to PC1 to R1, PC1 to R2, and PC1 to R3, and finally PC1 to PC2. And also we do pinging from PC2 to R3, PC2 to R2, PC2 to R1, and also finally PC2 to PC1. We also will at the initial time we will also ping for its gateway. 10.2 is network ID, sorry, IP of the PC1, and the gateway will be 10.1 we will be giving from R1, and then also from PC2 we will be pinging to its gateway 20.1. 20.2 is IP that we uh, assigned for PC2, and let's right now build a logical network right here with the actual devices in Cisco Packet Tracer. Okay, we have taken R1, and this is R2. Let's switch it. This is R2 and R3, and let's take in devices PC1 and PC2, and let's give connections copper straight through for PC2 router connect to gigabit ethernet. Let's check the connections and connect to as and copper straight through for PC2. Here we have given also G0 by 0, and let's take copper crossover for the same devices from first. Let's take for R1 to R2. We have taken 0 by 1 and connected to 0 by 0, and R2 to R3 we are connected with a 0 by 1, and here 0 by 1, And let's check. Yes, our connections are. Yes, let's check the interfaces. 0 by 1, 0 by 1, 0 by 0, and everything is same with the topology we have created. And let's give this. Let's first configure the router one. The initial dialog no. Enable T, and let's choose the network G0 0. The IP address 192.68.10.125.0. Let's check if the connection is up. Here we see our connection is up, and let's configure the another interface G0/1 interface G0/1, and the IP address 172.168.1.1. Let's check what IP address we are given. 1.1 and 255.255.252. No sure why we have given 252 for the 172 and 250 for the 192, because it is a class C address and 172 is a class B address. 192 is a area local address that doesn't go wastage in any IP address how many you have given, but the class B is a reserved IP address. So when you give more IP address, you have to buy more IP address. It will be wastage of a network and also the money you pay. So we have to get lease links with our linked networks. When we give 252, we will get host to host, and when we give 0 here, you will get 255 host. Let's specify OSPF. For the specifying OSPF, you have to use the command router OSPF 1. Here, what is the 1? 1 is a process ID. Process ID you can take whatever it is, 1, 10, 20, 30. Process ID ranges from 1 to 65,535. Let's check how we will know process ID. OSPF question mark, oh sorry, get back, exit, router OSPF. Here you see ranges from process ID ranges from 1 to 65535. You can take any number from 1 to 65535. Let's check if it's a true or not. 65536. It says invalid input detected, and let's take 65. Here we go. It's a two that I have given, but yeah, let's go ahead with that. Let's change the router ID, exit, and let's make it OSPF 1. And network, what are the network we have to choose? Whatever the adjacent networks we have here, that are the network we are choosing. What are the adjacent networks we have? Y 172, 168, 1.1, and the another adjacent network is 192, 168, 10.1. And let's take the adjacent networks 192.168.10.0. and we have to use a wildcard mask right here because we have to invert the host, and we have to only specify the host, not any network. So here we comes with the 255, and which area we have to specify the area here, area 0, and the next network 172 and 168 dot 1.0, and here you go with wildcard mask 0.0.0.3. Why we given 3? We have taken the subnet marks at the last update is 252. 252 subtracted from 255 will be remaining 3, so we have taken 3 IP addresses and area 0, because why we mentioned area 0 again, because it's a single area OSPF we are considering right now. And right, sorry, exit right, uh, right, and what is right command? That writes the all this configuration into the memory of the router. Even you don't give it, it saves the configuration automatically. And let's configure the router to enable conft, and let's specify the IP address interface G0/0 IP address 172.168.252, and here we go. Now shut down, and let's see if the connection is up. Here we check the connection is up, and let's specify the interface 0/1. And here we go. Let's assign the IP address, what the IP address we want to take right here, 172.168.2.1, yes, 2.1, 255, 255, 255.252, better one, better one. Let's specify the OSPF. What is the process ID? Same one. And the network. What are the adjacent network we have connected B? And one is a 1.0, another one is 2.0. Let's specify the 72.168.1.0. The wildcard mask 0.0.0.3. And which area? Area 0. And here you go. Network again. 172.168. Uh, no, sorry. Let me back to here. 2.0.0.0.3. Here I mentioned the area 0. Go ahead. And then right. Let's type this command, show IP OSPF neighbor. Here you see we got a neighbor network from 10.1. It's a 10.1 network, and let's try to ping the neighbor 192.168.10.1. Here you go, we got the ping, and also let's ping to the 172.168.1.1. Here you go, we got the ping from there. It is responding us. Yes, brother, I mean here. Yes. Oh, sorry. Shouldn't be clicking there. Sometimes we have to be out of the state. Let's go. Enable. And here on T. And here we will first to no IP domain. Look up. I don't want to mess up. Just give the command. If you don't understand why you use this no domain lookup, I will explain you in a minute. Let me take a new router. I don't want to really grab up to the router. And we have this router, and let it go ahead and pull it up. Yeah, and enable. And here we type the misspell command and see what will happen. Actually, you have to give space for configuration terminal, but let me don't give. Here you see it says conf domain server translating, and it checks in the database if this command is existed, and it takes a lot of time to do this process. So what we do is executing this command. So in the router 3, no IP domain lookup. So then when you give any wrong command, it doesn't go checking for the wrong commands in the database and directly gives you the incomplete or incorrect command. So right now we go ahead and specify our thing in interface G0/1. Go ahead, specify the IP address right here 172 dot sorry 170 that G0/1. Let's check what IP address would be 2.2 68.2.2 and 255.255.252.0.1. No shut, they will be shutting up. And interface G0/0 and the IP address 192.168.1 sorry 20.1 255.255. And then 0 don't be shutting up. Yeah, the connection is up right now. Router OSPF 1, and then we need to specify the network of our local area network 192.168.2.0 sorry 20 or 2 20 okay 20.0. Now go ahead 0.0.0.0.0.25. And what area 0. And here we go network wait network 168.2.0 2.0 0.0.0.3. That would be wildcard and 0. Why network never be the network network. There you go. Let's change this. Write this. Get back to escalation. Sorry. And pin 172.168.2.1. Do you see that? Do you see the brother? Do you see that? We got the ping. Let's configure the pieces also and it's taken long time, brother. 192.168.10.2. Let me copy. Don't want to get along with that. Right? Don't take a risk. Do you have a shortcut, brother? I have this one. 20.2. Copy all. Let's switch to the subnet. Okay. Get back here in the command prompt. Ping, paste one. I'm getting like that would be wasting time. 72.168.2.2. Getting reply. Go ahead with the 2.1. Getting reply. And 1.2. Dot 2. Getting reply. And go ahead with the 1.1. And me again. The same one, brother. 10.1. Yeah. 10.2. Sorry, we didn't configure the PC. We have to configure the PC one. I have configured the 10.2, right? Why? Yeah, it will take time. One packet will be lost and the next one will be getting read. Yes, here we see. One packet will be lost and next one will be into our database. So I don't want to check from PC1 as we got from PC2. If you want to, let's check. It's okay. It doesn't take much time. Just 1 or 2 minutes. Ping 192.168.10.1 for each gateway. And I want to do trace route instead of pinging each one. Trace route or tracer or trace route, whatever. Let's try with the trace route. Um, tracer and 20.2. Here you go. What we have here, our gateway 1.2, 2.2, and 20.2 directly reached. It hops each network for gateway at the beginning and directly to the network interface for the PC2 and directly the PC2. We don't need to ping each one to check because we directly reach, so we don't need anything. So it is OSPF single area, and I hope you learned something. And I'm going to wind up this lab for today, and I will make this package available in the description. So and you will download this and execute. If you have any doubt, first try to do execution, and if not, just download this packet file and open with a Cisco Packet Tracer and check the connections and commands. And I will also put the commands in a description, and you check it in a file, and you check it, and then just compare with your configuration if you have any error in that, and then we will see. Okay, thank you. Thank you. And before going back, let me tell you a trick. How do you go better with if you have any error? First of all, let's take you have all this configuration, and let's go. There is a search 150 and message list new asset list, or it doesn't show any configuration. So you have until here we have configured all the commands. Copy all these, copy all the commands, and make a page like this in the notepad. Let me open the notepad. Put a title like this, router 1, and, and paste the commands right here, and here put another subtitle as a router 2, and get, get the commands from the router 2. We are right, and from the starting, copy this, paste it here, and here you have all the configuration that you have done. And like this, you copy the commands and paste it in your notepad, and also download my commands from the YouTube description and compare with your configuration if you have any error, and then reconfigure your file and check if you have any mistakes and learn through that. Most of the time I better say don't be downloading any file and thing, and you try yourself, and if you doesn't seems to be coming there, and again watch the video and again try to reconfigure, or first check with troubleshooting commands. We have a troubleshooting commands: ping, trace route, and what else we have, this sh command, so IP OSPF neighbor, and show IP route, like these commands, and check with these commands. If you still can't find, then try to wash one side again, and let try to reconfigure. And first, if you use a ping from, if you have any error in video, try to ping from PC1 to gateway, and then PC1 to router 1, and then PC1 to router 2, and like the one by one. Wherever you cannot get the ping packets from PC2 to that interface, then you check the interface might be error, or error in defining the IP address, or from the router 1 you cannot get route from the R2, or check this configuration between the R2 and R1 and reconfigure it. And same like PC2, if you cannot get the route from PC2, like if you cannot communicate with the router 2 from the PC2, and check any connection between the router 2 to router 3 and PC2 to router 2, and trace route it. If you can get this router 2 interface, first ping from PC1 to gateway, and then PC1 to router 3, and sorry, PC2 to router 3, and PC2 to router 2, and PC2 to router 1, like one by one. After you learning the route, then you check everything again and reconfigure it, and try it again until you get the successful routing path and successful ping from PC end devices to end devices on the different networks. Thank you. I hope you learned something from today's video. And we will continue with the next video. That will be OSPF multi-area network, and we will discuss the remaining there.